Pentru colegii noștri. Okay, let's see. Okay.
Bine, bună seara, bine ați venit la... Încă n-am anunțat bere și pizza, deci bine ați venit la meetup-ul din septembrie, ultimul înainte de hackathon-ul de JavaScript, care va avea loc luna viitoare între 20 și 22 octombrie. Puteți să aplaudați. Meetup-ul din seara asta este unul special, pentru că este organizat în colaborare cu prietenii de la Ethereum PPRS Meetup. Aplauze! Este special pentru că e o seară importantă, pentru că vom avea speaker valoroși, dar și pentru că EveryMatrix este a doua, a treia, a patra oară când ne sponsorizează cu bere și pizza. Da, asta este o companie care a înțeles în sfârșit ce vrea developerul. Tot în această seară, Aurel de la Ethereum oferă un Ledger Nano S ca și premiu la raffle-ul în care tocmai v-ați înscris. Cred că are Ethereum pe el sau ceva. Da. În felul ăsta aveți o monstră a ceea ce va însemna, fără să spun prea mult, JS Hacks, hackathon-ul de luna viitoare. Nu, în sensul că vor fi foarte multe premii, nemaipomenite surprize, avem. Agenda din seara asta. Trecem rapid peste ea, prezentarea despre React al lui Victor de la EveryMatrix, după care avem panelul Ask Me Anything cu Aurel Iancu și Ștefan Neagu. Aurel Iancu reprezentant comunitatea de Ethereum din București, Ștefan Neagu Organization Lead la arc.io. Câteva anunțuri înainte de a începe cu primul speaker. Alex Proca de la Vox Days este aici să ne spună câte ceva despre conferința pe care o organizează în Cluj. Alex?
Salutare, cine auzi de Vox Days sau de Vox? Să mă dau aici, nu stă în fața mea. Avem plăcerea să colaborăm cu Ciprian și după 2 evenimente de succes în București o să ne extindem în Cluj. De asemenea, o să facem următoare evenimente de martie la anul și vă invităm, mai astăzi din Cluj sau dacă aveți prieteni, să ne vizitați. În general, conferința noastră este o conferință care are diverse track-uri, cum ar fi backend, web, mobile, frontend și este o conferință tech. În general, am auzit ceva, full stack? Da. Încercăm să aducem speaker internațional și încercăm să aducem toate comunitățile împreună, să facem schimb de idei. Dacă sunteți în Cluj sau dacă sunteți în București, în primăvară, puteți să folosiți codul acesta și să ne vedem la Vox. Mulțumesc frumos!
Referitor la JavaScript din 20-22 octombrie, avem și un site. Stai. Gata. Deci vă invit și e ceva ce puteți deja face din această seară, să vă înregistrați. Apropo, câți dintre voi vreți să veniți la hackathon-ul de JavaScript de luna viitoare? JavaScript și blockchain. Ok. Vă rog frumos să înregistrați-vă cât mai curând, pentru că sunt locuri limitate. Anul trecut am ajuns să programăm pe masa de ping-pong. După aia, asta zic, știi, dar câți dintre voi care nu știți că vă veți înscrie, câți dintre voi, hai să spunem așa, încă sunt în dubiu, ar vrea, dar nu știu. Și care, ok, în dubiu. Okay. E vorba de tehnologie, e vorba de altceva, e timp, e nevastă, sunt copii. Okay. E clar, după meetup-ul din seara asta, o să vreți fiecare dintre voi ca pe perioada unui weekend să creați un ICO și așa că o să veniți la GSS peste mai puțin de o lună. Deci aveți aici registration for Bucharest și să duce la bucharest.gsx.io. Aveți câteva challenge-uri pe care le-am pregătit. Ele nu sunt cu titlu obligatoriu. Dacă aveți o idee, o echipă, puteți evident veni cu ea. Sau, mă rog, cu ele și ideea și. Ca și agenda. Formatul este următorul. Vineri seara ne întâlnim, începem hackathon-ul în sensul că aveți un minut în care să prezentați ideea la care doriți să lucrați. Și de obicei se spune ceva de genul, ok, sunt, spre exemplu, Ciprian, sunt frontender, vreau să fac nu știu ce cu blockchain, habar n-am de backend, am nevoie de cineva care să mă ajute cu chestia asta și mai am nevoie de cineva pe zona de marketing. În felul ăsta oferiți posibilitatea celor care nu sunt într-o echipă să vină în echipa voastră dacă ideea este apetisată. Asta se întâmplă vineri seara, iar scopul este să ajungem undeva la 10-15 idei. Anul trecut au fost 18. Sigur că pe parcursul weekendului vor supraviețui, să zicem, din 18 anul trecut au supraviețuit 10-13. Sâmbătă și duminică se lucrează la asta, sâmbătă după masă undeva la ora 16 se va întâmpla demo day-ul, care înseamnă că veți prezenta ceea ce ați făcut pe parcursul weekendului în fața acestui juriu. Este vorba de Flex Crișan, pe care îl știți de la meetup-ul trecut, Aurelian, pe care o să știți din seara asta, și François de la ARC, care va și avea un workshop de blockchain de sâmbătă între 11 și 13. Deci, ce să zic, o să fie un hackathon interesant. Mentorii, o parte dintre ei știți de anul trecut. Sponsorii, fără de care un astfel de eveniment nu ar fi posibil, și pentru că vedeți astfel de sponsori înseamnă că sunt și premii pe măsură: Ethereum, România, ARC, Qualitas, GoPro, Netopia, Aqua Carpatica și Sâmburești. Wow! Deci domeniul de Sâmburești. Și e și pizza și atât. Dumnezeule, trebuie să pun și logo de la Jerry's Pizza acolo. O să fie și pizza. E ok, putem să și aplaudăm pentru sponsorii ăștia, că ne ajută să... Iar ultimele cuvinte și mulțumiri din tot sufletul pentru echipa de anul ăsta, în ordinea numelor de Pedrigău, Andrei Antal, Andreea Sprut, Mihai Popescu, Diana Miron, Valentin Tuleac, Olivia Lăpușneanu și cu voi dumneavoastră ultimul pe listă eu. Ciprian Bărădesc, da? Bine, acestea fiind spuse, tot în aplauzele dumneavoastră, primul speaker al seriei, Victor de la EveryMatrix este React.
Hello, everyone. Test. Hello, everyone. My name is Victor Herman. I'm a JavaScript team lead at EveryMatrix, and I'm going to speak about React tonight. This is about a new technology. It's not something groundbreaking or something new about it, but the thing is that we did something very one of a kind, I think. There are some projects developed on React, like Wix, that enables a user with no JavaScript experience to create a fully fledged website. But these are rare projects. You don't find them everywhere, and there's not a whole lot of documentation. There's not a whole lot of answers about it. So if you basically need to create something like this, you need to create it from scratch. Let me tell you first about how this presentation came to be. So like 2 months ago, somebody from our HR department asked me to do a JavaScript presentation about Angular 4, because Angular 4 is so hot and new right now, and everyone wants to hear about it. And I was thinking that I don't know anything about Angular 4, I haven't worked with it, and probably there are a lot of people here who already use it, so it would be probably embarrassing for everyone. So I go to my colleagues and ask them about suggestions of what should I present. And one of my colleagues comes with a suggestion, talk about love life after marriage. And I'm thinking, I've been married for 6 years, I have some good insight about it, but again, probably half of the presentation would be empty. So this leaves me with the only thing that I know how to do well, which is building a CMS in React that I have been doing for 1.5 years. And for the first time that I had the idea of this presentation, it's like I think 1 year ago, when I was working on this component named register form that I have been developing for 1.5 years. And 1 month and a half. And it's been very painful because it's not a simple component. It has already been developed, and I need to integrate it to the CMS. I have no idea what I'm doing, as you can see here clearly. And it's been very hard. When I finished, after a lot of pain, sweat, and tears, I'm very satisfied with what I did. And probably like everyone who did something hard for the first time, I think I'm a god. Of course, I'm not a god because we had to refactor everything that I did in the meantime, but this actually was the first component that we integrated with the CMS. It set the rhythm and the pace of the project. And I'm still very happy that I got the chance to work on this at that point in time. Let me do a short introduction about EveryMatrix. Probably most of you have never heard of it. In the presentation, I'm DynamicReact JavaScript team lead. Actually, there are 5 divisions in EveryMatrix. DynamicReact is just one of it. We are a white label software as a service, which serve big and small clients on a lot of websites. So I think we have over 100 websites in production right now. And what we noticed about our clients is that most of the websites have the same functionalities, being gambling and sports, sports betting websites. So somebody very bright obviously came with the idea, let's do a framework of components. So we could be able from a CMS based on some RESTful endpoints to serve some JSONs that would generate a website, obviously without the need of JavaScript developers. So first of all, we had to choose the technology that we needed. And basically, we needed something that supports components, that is flexible and easy to use, that has a very wide support, because we might use some third-party packages. There might be bugs while developing, and if it is a framework that's not so well supported, those bugs might take some time to be developed, and we cannot be blocked by this. And we had to easily be able to write vanilla JavaScript for some parts of it and still work, be compatible with everything else. At the time of starting, Angular 2 wasn't released, it wasn't even beta. Aurelia Vue and Polymer were other frameworks considered, but we thought that the support is not enough, and this was a much too important project to risk it. So we chose React that had everything. The team that started working obviously had never worked with React before, and this was another problem. We had to learn React first, create a static website, and after that integrate it in a CMS. So at first we thought a lot of people does this. What they do actually is create something like Bootstrap, and then just use those components to create the website. We didn't thought of having everything in the CMS. We just thought we have some components that could be reusable across multiple websites. It became clear that Bootstrap is not enough because it covers just some basic needs for everyone. And some other problems emerged while developing our website, like the fact that this button here might need to support different layouts. It doesn't need to support only text, it might support HTML. And for the CSS integration team, which was actually a different team that does the styling for those, they might come to us with requirements that we could not support. So we need to give them the capability without any JavaScript development to use this component right away and configure it from a CMS. So after some long and hard thinking, we came up with this architecture. We have a core, which is the main powerhouse behind the project. It starts the project, it provides an API, so you can put any kind of middleware you want into Redux. It also provides the store and some other abstractions for the communication with our backend, the WebSockets, and with CMS. It also does some watching over the state of the application. So when something that is of interest from CMS, which is configurable, changes, this core does a new call to the CMS to get the new data. Like for instance, when I'm not logged in and I log in, without refreshing the page, I see that the state of the user changed, and I need to make a new call to the CMS to get the new site layout, which is might be different from a logged in user. We also have some utilities. We have some React components which are something like Bootstrap, but much more complex. We also have a very interesting thing here, circular dependency, but I'll talk more about this later. And on the right side, we have the actual website, which are higher order components, containers from React that can be used through the CMS. Okay, we had to make a lot of design decisions. Again, we had no idea what we were doing. It was more like a trial and error programming. And in the end, we decided to take the blue pill and drop most of our knowledge earned through years of experience on the front end and just do what felt right at the moment. Of course, keeping in mind best practices, but not taking them as a dogma. We need something really dynamic. We need something that could fit our needs and could fit every future request from the business that we might have. It's more like a unicorn. So some of the decisions that we took in the process was to have no router, because obviously all the pages come from the CMS and they are not built manually by everyone. So our router is just a star here that matches every possible route that might come or the user might put in the URL. And based on that, we have a sitemap that comes from the CMS. We do a matching, and based on that matching, we get the data from the CMS for that specific path. We also match the dynamic and the static part of the URL, because we don't know in our router if we have a user ID or if we have a game ID or something like this. We need to know which part is dynamic and which part is fixed. And based on that, we need to know how to send the data to the CMS. We also decided to make a huge view controller, which is actually the whole container for the HTML and the components rendered in the website. What you see here is the constructor for that. Well, actually, I deleted some code that's much bigger, but this is a basic constructor. And the state that you see is the CMS data that comes through JSONs in the front end, and through some mechanisms is transformed to components and then rendered to the page. This is the render method for the view, for our main view controller. As you can see, it renders the page content after it has been processed and mapped through some of our code. The main building block for this is actually, excuse me. Okay, the main building block for this is actually what we call dynamic component. This is a component used throughout the whole website. It does multiple things. We have written this after like 6 months into the project. We took code from all over the place and put that code just in one place. We have two static methods, mainly the fetch wake link component, which is for lazy loading components. So if you enter a page and you do not want to, you have a lot of content, you don't want to load anything at once, based on the user actions, if there are multiple tabs, when the user clicks a tab, this component goes to the CMS, makes a request for that specific component, gets the data, and renders the component. We also have the render context component, which is actually somewhat of a hack at some level, because what it does, it goes through all our packages that I presented earlier and are published to the NPM and are obviously installed through an NPM install. And it searches for the components folder, and from that components folder, it takes all the components, it references them by name and by path and by some other identifiers. And when I receive the data from the CMS, I know which component goes where based on this render context component that Webpack does for me when I bundle the code. The way we use it is pretty straightforward. The component prop is something that comes from the CMS mainly. We might enhance it at some point if we need to. And the other props are just props that we would pass to this component, even if we don't have dynamic component. If we use types item, we would pass the same props here, and it work in the same way. This gives us the flexibility that we need to be able to replace any components in the future in the CMS, because you might realize at some later point that a component it was a button in the start, it became an anchor or stuff like that, and you cannot have an anchor or button here. You cannot write all the ifs that you need. So for brevity and for good architecture, we use this escape hatch. We also have circular dependencies, like in the core. When the core makes calls to the CMS, before the application starts, we need to show a model to the user. And this model, obviously, it's a component more like a bootstrap component. And the way we bypass this, we know this is a hack and it's not a good architecture. The way we bypass this is by using requiring sure. We make requests, and we hope, we pray that components will be there, the model will load. Until now, the components and the core always go together for all the websites, so we don't have a problem. In the future, we might need to refactor this approach. But as long as it works, we are satisfied with it, and maybe sometime in the future we will get to refactor it with a better approach. Other decisions that we took along the way is not using server-side rendering, which was all the fuzz and jazz when we started. We felt that we didn't need it, and eventually it will have to go away as the crawlers will gradually get better in indexing different websites. We also felt the need to forget everything that every tutorial tells you, to have a lot of DOM components and a couple of containers, of high-level containers that encapsulates all the logic, like the icon component, that takes its own data from the server, from a static server based on some configuration passed from the CMS, and it changes that based again on the state passed from the container above. We did this because it's easier to have just one icon and pass active and inactive states to it than have two icons and render those based on your state. It's obviously easier, and this is a problem that we had along the project because we didn't know always where to put our logic or business logic and state and so on. The dogma says that you should have a couple of higher order components and a lot of DOM components, and those higher order components should do all the controlling of the application. But for a CMS, it doesn't always work. We might need some components that are singletons at the side level, and that should have some logic and some checks in the CMS that is not so easily available and readily available immediately. Some other things that we did and are not quite by the book, it's components that do not render HTML. When React started, there was a lot of talk about HTML rendered by the components. A lot of people said this is like going to the IS6 days that I have been working, when I have been working on the IS6. And we felt that in order to hook in the component lifecycle and in the React Flux model, we needed sometimes components that just provided functionality, like we needed to do a specific script injection for some third-party integration. We needed to show some errors based from the CMS, but those errors were not immediately available because the website didn't start. It's like you start the website, you see that you have no internet, and you need to render something. Or the call from the WebSockets fails, and you need to show some error, but that error is not rendered into the page, it's just injected directly. Okay, we also decided to use context. This was actually quite a heated discussion among the team. The React documentation advises against it because they say context is not such a great API, it might change in the future. We actually noted that Redux uses it, and if Redux uses it and React stops supporting it, everything from our application will fail because we use Redux. And we always kept some fallbacks in case context doesn't work anymore. We also had to drop the index.js that's used in most JavaScript projects. The main problem with it is that when writing unit tests and importing just a component, you have to import like 2 or 3 or 4 modules because you import index.js. Index.js takes everything from all the modules, and then you have problems for performance for unit tests, and you have problems with mocking from jest because some things are harder to mock, and you end up with a huge bundle just for one unit test, which is not really so great. We also had to write some highly dynamic things like this here. Let me explain it. This ID and this name are actually properties passed from the CMS for input fields. And based on that input fields, we use them for HTML4. What this does is that it takes a unique identifier for each input field. So anytime a user goes to an input field and changes something, the state of the form that will be later submitted to the server changes. So if a user comes and types the username, and I know that the name of the field is username, every time he updates it, the name of the variable that is saved to the state of the higher order component will be actually the username. So if somebody from the backend changes the name of a key from their backend, we can just go to the CMS, change it for all the websites, and it will continue to work for all the websites that use that version of the API. Also have a data layer component. This enables the user to put in the code things like user profile name, which are actually paths from our store, from our backend store. How we do this is that we parse the initial code from the CMS, we regex everything like this, and we replace it with a data layer component that takes this path as a property. And based on that, we create an array, because React will already render that component if it is an array. And at the runtime, anytime you need something from the store, you can access it like this and use it. It's very convenient for the user to be able to have access to everything in the store, every component, anywhere, anytime. Also have a CLI tool that helps us with various things like setting up the development environment for the users that work on the framework, to build the statics and the minified code for the CI. To init, the init command actually copies everything from Git and installs a new project for you to work on from a blueprint that we have. Let me show you actually an example of how everything looks. On the left side, what we have is something from the CMS. As you see, we have a high level of nesting. On the right side is the result from this nesting. So you can do any type of change. On the left side, it will be reflected immediately on the right side. We will be able at some point in time to enable users to do this in production. And it's quite powerful if you want to change something fast or set up a promotion or stuff like that, because you won't have to do a full development cycle, do all the testing, do all the development, and so on. You can just do a preview, test that preview, and everything should work. On the long term, what we have is a core of components that are shared across all the websites and are reusable. They will be used by everyone, and every change here might break the website. And on the right side, what we have is custom components for every website that are used only by one or two websites and don't risk breaking anything when you change those. So the way we sidestep this is by using semantic versioning. Actually, we're in the process of developing this right now, and we have to make sure that we do as little breaking changes as possible on the long term. Okay, other technologies that we use are the technologies for automated testing. We have unit tests, we have Git hooks for deploying all the CIs. So every time you do a deploy, the unit tests and the ESLint is run. We still believe in ESLint, and we do a very thorough check before pushing any code. This is actually the team that worked on it. Adrianatsu is our PEX team leader. I want to mention him because today is his birthday. And the other guys, thank you very much for working on this project with me. And thank you very much for being here. If you have any type of questions.
Question, guys? Question?
I have a question.
Sure.
If one of your clients wanted to change the CSS and have a specific version of colors and different types of